Hello everyone, welcome back to Mission 600 Physics Mastery. This is the second lecture and I'm going to discuss some questions from PYQ from laws of motion. So let's get into it. So I'm going to explain the concepts through these problems. Okay, let's go on. First question, a balloon and its content having a mass capital M is moving up with an acceleration A. So we have a balloon and it has got a mass capital M and it is having an acceleration upward acceleration A. A balloon, how is it going to have upward acceleration? Even though there is gravity here, gravitational force is acting on it and yet it is going up because of the force of buoyancy, right? So force of buoyancy will be upwards, and obviously force of buoyancy is more than gravitational force, that's why it is having an acceleration upwards. That's the first statement. The mass that must be released from the content so that the balloon starts moving up with an acceleration 3a. So I'm going to remove certain mass out of it. So the balloon size will be the same, but balloon load will be reduced, and so the mass will reduce. Let's say delta m is the mass that I'm going to remove. Because of that, the balloon mass has become m minus delta m. And now if I write the forces acting on it, weight which is going to be reduced, and then you have force of buoyancy B, and I'm assuming that force of buoyancy is not going to change because size of the balloon is not changing, just the contents have been taken out. Force of buoyancy depends on volume displaced, and that's what you have. Now it is supposed to go up with an acceleration 3a. Then what is delta m? That's what he is asking. So we'll just have to write Newton's law's equation. Here, what is the first equation? You will have B minus capital Mg equal to m into a. That is equation 1 from the first scenario. Alright. From the second scenario, what do I get? B minus capital M minus delta m into G is going to be equal to capital M minus delta m into A. That is going to be the second equation. So this is second equation, I have it. Now we need to solve these two equations. I don't want force of buoyancy because they didn't give it. So we'll just take the subtraction. If I do 1 minus 2 if I consider, then you see that this B gets cancelled out and Mg also gets cancelled out. Then I'm going to have delta Mg here and minus delta Mg you will have. So there is a reduced weight, and what do I get here? Capital M into A and capital M into A is gone, and here you will get 3a acceleration is 3a. So then I'll have capital M into 2a there, and then delta M into 3a you will have it. So this is going to be capital M into 2a minus delta M into 3a. That's what I have. So delta M terms, I'm going to take it this side. Delta M into 2a, 3a minus G equals to 2 capital M into A, and from there I can calculate delta M equal to 2ma divided by 3a minus G. That's what I'm getting. So it's very straightforward if you understand that. Main idea is that force of buoyancy is not going to change. So acceleration is changing because net force has changed. Net force has become 3 times because acceleration has become 3 times there. So that's about the problem, first problem. Then let's go to the second problem here. At any instant, the velocity of the particle of mass 500 grams is given. So they had given velocity, and you see velocity is varying with time. Okay. If the force acting on the particle at t equal to 1 second is this, then the value of x is. So they gave velocity given, and we have to find force. Given velocity, how to find force? What do you think is the roadmap there? So one way would be you calculate acceleration from here, and from acceleration you apply Newton's law to find the force. That is one method we can go for. So given velocity, how to find acceleration? That is basically differentiation you will do. Differentiation of velocity will give acceleration. From acceleration, apply Newton's law to find the force there. So differentiate it. Let's calculate velocity differentiation dv bar by dt. and that is going to be 2t differentiation is 2 I cap plus 3t square differentiation would be 6t j cap. That is velocity differentiation, which is acceleration. Okay, very good. Once I have acceleration, and assuming that there is only one force acting on it, then the force must be equal to mass times acceleration. Mass they had given 500 grams, which is half a kg. So this is going to be 1 by 2 times 2 I cap plus 60 j cap. That is going to be I cap plus 3t j cap is Newton. That is the force there. Now they are asking the force at t equal to 1 second. You substitute there. You will get I cap plus 3 j cap, and that 3 is going to be x there. So x is basically 3 is the answer there. So very straightforward. Knowing velocity, how to find acceleration, from acceleration, how to find force. So from kinematics to dynamics, that's a linking problem that we have here. Next question. So this is equilibrium question, right? You would have seen many kind of this is kind of problems there. Let's try to understand. A body of mass 1 kg is suspended with the help of two strings making angles as shown in figure, 60 degrees here and 30 degrees here. The magnitudes of tensions T1 and T2 respectively are. So basically net force 0, net force horizontally 0, net force vertically 0, you can write it. So we can resolve the forces horizontally and vertically and sum it up and equate to 0. That is one thing. But I want to use Lami's theorem here because there are three forces acting. So we can use Lami's theorem whenever the net force of three forces is coming out to be 0 then. So for that I need angles here. You see here 60 degrees, 30 degrees, meaning these two together is 90, total 180, that means this will be 90 degrees. Okay. And this is 90. Alright. That means this total angle is going to be 90 plus 60, 150 degrees. And what about this angle? This is total is 120 degrees. Right? Now apply Lami's theorem. mg upon mg by sine of opposite angle 90 degrees, and that is equal to T1 upon sine of opposite angle sine 120 degrees, and that is equal to T2 by sine of opposite angle sine 150 degrees. That's the answer we have here. Sine 90 is 1. So I'll get T1. T1 is equal to sine 120 into mg. Right, by taking sine 120, and same way T2 equals to sine 150 into mg. Okay, sine 120 is cos 30, cos 30 is root 3 by 2. Okay, root 3 by 2, and mass how much they had given 1 kg. G I will take 10, mg will become 10. So that means it is going to be 5 root 3 Newton. And same way here, sine 150 degrees is cos 60, which is 1 by 2. 1 by 2 into 10 is 5 Newton. So T1 is 5 Newton, T2 is 5 root 3 Newton. That is the answer there. I have just used Lami's theorem. Of course, other method is resolving the forces along horizontal and vertical direction. I hope you got that. Next problem. Yeah, similar problem. Again, this is also on equilibrium related. Now I would like to use resolving. Earlier I have used Lami's theorem, but I feel that it will be much easier to solve using resolving because angles are simpler. Resolving becomes very easy. So let's look at it. A block of mass root 3 kg is attached to a string whose other end is attached to the wall. An unknown force F is applied so that the string makes an angle 30 degrees with the wall. Then the tension is okay. So I'll resolve tension here, because mg and f are already perpendicular to each other. Let us not disturb them. So here you have mg down and f is there. I'll just resolve only the tension there. So if you extend that line, vertical line, this would also be 30 degrees. Parallel lines, this is transversal. So T component along the vertical would be T cos 30. And T component along horizontal is T sin 30. Now horizontal equilibrium, T is no more. Horizontally what do you have? T sin 30 must be equal to that applied force. So force is balancing the T sin 30, And vertically, if you consider T cos 30 is balancing mg. Alright. Now what are they asking? They are asking you to find the tension there. Right? I don't want the force. If they just ask you to find the tension, you can use this relation T equals to mg by cos 30. So m they had given root 3. I'll take g 10. Okay. Cos 30 is root 3 by 2. So you will get 20 Newton. That's the answer. We have it. So it's very simple. Resolving, I went to the previous question. I used Lami's theorem. Now in this question, I'm looking at in terms of resolving that. Right. Let's look at another next problem. A block of mass 200 grams is kept stationary on a smooth inclined plane. So they gave smooth. That means friction is not considered. Okay. By applying a minimum horizontal force F equal to root x Newton as shown in the figure. So we need to keep it at rest. Keep it at rest. Then I think minimum is not correct. Minimum is not going to be just one unique value you will have it because it's a smooth surface that we have. But anyway, let's solve it. So here if you look at it, along the normal, you have normal reaction which is self-adjusting. Depending on the pressing that you are doing, it will give the same amount of force. So forget about normal reaction. Just focus on the forces along incline. You have mg component down, that has to be balanced by force component. So you know that along the incline, mg component is going to be mg sin theta. Right? Mg cos theta, mg sin theta, you might have used it many times. That's okay. That is down. Who is balancing it? So you have applied force in this direction. I'm just taking the line of action pushed this way. If this is theta, this will also be theta. Then F component along the incline is going to be adjacent side. So it will become F cos theta. So F sin theta normal reaction, they will balance it. Don't worry about it. Along the incline, if you look at it, only two forces are there, which are F cos theta must be equal to mg sin theta, or otherwise F equal to mg tan theta. Theta is 60 degrees. You can substitute there. Mass is 0.2 kg, 200 by 1000 into G10. All right. Tan 60 is root 3. So you see that these 3 zeros gone. You will get 2 root 3 Newton. That is the force there. 2 root 3 can also be written as root 12. So x is 12. That's the answer. We have it. So I hope it's very simple only. So I'm not writing the earlier problem. I've written equilibrium along y direction, vertical direction. Now we are writing equilibrium along inclined way. So basically very simple question. These are all PYQs. I've just taken latest PYQs. Okay, next problem. This is actually inspired from a question from Erudov. It came many times in this form. An object with mass 500 grams moves along x-axis with a speed v equal to 4 root x. Then the force acting on the object is. So they gave velocity and they are asking you to find force. Alright. Earlier also we have seen the same question. One method would be you differentiate. Alright. dv by dt is okay, but v is given as a function of x. This will also be equal to v dv by dx. So that you will get acceleration. Once I get acceleration, force into acceleration is going to be force there. That way you can calculate it. That is one method. You have it. This is method 1. Alright. There is another method for this particular problem. Just by comparison purpose. First you just square it. What do I get? V square equal to 16x I get. V square equal to 16x. And now you recall kinematic equations that you have seen it. You will have V equal to u plus at, but that is in terms of time. S equal to ut plus half at square. Again t is there. I don't want t. The equation which doesn't have t, x velocities, right? V square minus u square, if you write V square minus u square equal to 2ax. If you compare it like this, you would see that in the place of 2ax you have 16x. Alright, u square is 0, initial velocity is 0, and 2ax equal to 16x there. So it is actually moving with constant acceleration. You don't have to do differentiation. Even if you do that also, you will get that. So by comparison purpose, you will see 16 must be equal to 2a Otherwise, A equal to 8 meter per second squared. So you got the acceleration there. Once we have acceleration, then force we can always calculate. Force is equal to mass into acceleration. Just magnitude if I want, mass they gave 500 gram, which is 0.5 into 8. So you will get 4 Newton, right? That's answer, very straightforward, but comparing with kinematic equation. Let's go to the next problem. Right, a body of mass 2 kg moving with a velocity initial 3 I cap plus 4 j cap meter per second. Look at it. It is in XY plane. Okay. Enters into a constant force field of 6 Newton, magnitude is 6 Newton, and directed along positive Z axis. So it's not in XY plane. Force is along positive Z axis. Okay. If the body remains in the field for a period of 5/3 seconds, then velocity of the body when it emerges from the force field is. Okay, so we have force which is a 6 K cap Newton, constant force. Once I have force, I can calculate acceleration, that is force upon mass, which is 6 divided by 2, which is 3 K cap meter per second squared. So I got acceleration also. Once I have acceleration, they are asking you to find the final velocity. So final velocity equals to initial velocity plus acceleration into t. Acceleration is constant, so I can use these kinematic equations. What is acceleration? Initial velocity 3 I cap plus 4 j cap, that is initial velocity, and acceleration is 3 k cap into time interval they gave 5/3 seconds. So you see 3 gets cancelled out, you will get nice equation 3 4 5, 3 I cap plus 4 j cap plus 5 k cap. That's the final velocity. And they're just asking you to the magnitude, I think, right? Even if you want to find the magnitude also, it is very simple. Magnitude is that rho 3 square plus 4 square plus 5 square is going to be 5 square plus 5 square. 5 root 10 is 5 root 2 meter per second, you will get it. That's the magnitude. This is vectorially, this is magnitude there. So straightforward. Right, next. And this is about string constraint, very simple, straightforward question. I hope you are comfortable with power method, string method. So let us use that power method here to solve this problem. Okay, all surfaces are assumed to be frictionless. Okay, friction is not there. Pulleys and strings are light. The acceleration of the block of mass 2 kg would be. Right. So let's assume that here tension is T. Then obviously here also tension will be T and here tension is T. But here tension would be 2T. Alright. Because pulley is assumed to be massless. Net force on the pulley is 0. 2T should balance it. Okay. Let's assume that the 2 kg block is going up there, A1, and the 4 kg block is coming down, A2. If I get negative value, I can reverse the direction. That's not a problem there. So let's write Newton's law for this. Up the incline, you have T in the direction of acceleration. Down the incline, you will have minus mg, let's call it as m1, m1g sine theta. I'll substitute the values of theta and m1 in the end. And that is equal to m1 into a1. That is equation 1. Now, if you look at this guy, you have m2g down and 2t upwards there. So, if I write the equation, what do I get? m2g minus 2t equals to m2 into a2. That is the second equation. I have it. So I want to find only acceleration there. I don't want tension there. What do? I multiply this with this 2 and then add them. So twice of equation 1 plus 2 if I do, then what happens? This 2t and minus 2t gets cancelled out. Then finally what do I have? m2g minus 2 times of m1g sine theta is equal to 2m1a1 plus m2a2. So that's what I have here. Now if you want, you can substitute the values of m1 and m2. m1 is 2 and m2 is, I think this is m2, m2g. m2 is 4. So you will get this as 40 minus 2 into 20. 40 into sine theta, sine 30, that is 1/2, that is equal to 40 plus 40, 4 plus 4 times What do you have? 4 into A1 plus 4 into A1 for A2. You have it. So that means what do I get? Let me remove this. So you have 4 times of A1, 4 times of A1 plus A2. That's what I have. So this is 40 minus 20 is 20. 20 by 4 equal to A1 plus A2. Okay, that is one equation I got. Usually it's simply writing Newton's laws of equation. This is 1 and 2 together. Okay. But there are two unknowns and I got one combined equation. A1 plus A2 equal to 5. I am getting it. How do I find the other relation? That is where you will get constrained equation. So power method I am writing 2t into A2 must be equal to T into A1. Net power delivered by massless string, ideal string is supposed to be 0 because it cannot store energy in the form of kinetic or gravitational or strain energy. So net work done has to be 0. Power has to be 0. Differentiating you will get acceleration also. This is the second equation I will get, right? 2A2 equal to A1. What are they asking? Acceleration of 2 kg block. I want A1 only. That means I can eliminate A2. So A2 equals to A1 by 2. I will take from here and substitute here. What do I get? 5 equal to A1 plus A1 by 2. That is 3A1 by 2. So from there I will get that A1 equals to 10 by 3 meter per second square. So very straightforward. Apply Newton's law to this. Free body diagram, Newton's law, constraint equation. I have used power method here. Of course, there are other ways of doing it also. But I feel that it is much easier. So let's go on further. Right, next 3 blocks A, B and C are pulled on a horizontal smooth surface. Actually, this problem was given in NEET exam. Again, same database. So we got it in JEE mains as well. These are all PY questions anyway, PYQs. So what are they saying? They are applying 80 newtons there. They are asking you to find tension T1 and T2. So what we will do, we will take a bigger free body diagram first. Always remember, bigger the FBD is, easier it is because you will avoid lot of internal forces. So only external force horizontally is 80 Newton. So that 80 Newton should produce acceleration for everything. They are all going connected, common acceleration 5 plus 3 plus 2 times acceleration. So that is 10. That means A equal to 8. You will get 8 meter per second square is the acceleration you are getting it. Now I want, let us say T1. So to find T1, I'll just focus only on 5 kg block where the external force is only T1 there. So T1 should produce the same acceleration only for 5 kg block. 5 into 8, you will get 40 Newton. Very simple. Now I want to find T2. For that what I can do is I can take only 3 kg block free body diagram and solve, or only 2 kg block free body diagram and solve, or otherwise much better would be taking 3 kg block and 5 kg blocks together as one system where T1 becomes internal force and T2 is the only force which is pulling them together. So from there you will see that T2 equal to 5 plus 3 into the same acceleration whatever you are getting. 8 into 8, 64 Newton. Right? That is the answer you have. T1 equal to 40 Newton, T2 equal to 64 Newton. Very straightforward, simple problem. Right, let's move on. Right, next problem. This is diagram is required. You should be able to draw the diagram carefully. Nice question. Earlier there was one old IITJEE advanced question. On that I think they had given this problem. Let's read it. A block of mass M is placed on a smooth, placed on a surface having vertical cross section is this. So y equal to x square by 4, meaning y is vertical here. Coefficient of friction is there. It's not smooth. Mu is 0.5. The maximum height above the ground at which the block can be placed without slipping will be. So that's what they are saying. First, let us draw this diagram. It's a parabola, right? Quadratic expression you have. X square coefficient positive, meaning it is concave up. So y versus x graph is going to be like this, right? So symmetric about this, you will have even this side also, parabola you have it. So let us consider any point. Let's say I'm going for a certain height. Height is y here. At that point, I'll just draw a tangent. Let's say the tangent makes an angle theta. Now if I keep the body there, alright, the friction will be tangential. Friction will be tangential and mg sin theta is down. So mg sin theta is down the incline. It is something like, imagine you have an incline there. Alright. Mg sin theta is down the incline, friction is up the incline. So you might have seen even in board examination also, when you have an inclined plane, alright, and the block is kept on an inclined plane, they ask you to find this theta where it is about to slide. What is the maximum angle you can take it? And that angle is called angle of repose. This angle would be tan inverse of mu, if you remember it. So when it is about to slide, same thing happens there. So tan theta has to be equal to mu when it is about to slide. This is a concept of angle of repose you are considering. Actually, they gave a curved one. You draw a tangent. The tangent can be compared with the standard straight incline with certain angle, which is angle of repose there. So tan theta equal to mu. Mu is nothing but 1 by 2. But tan theta is also equal to dy by dx. Right? And that is going to be 1 by 2. Tan theta is dy by dx, slope of it. Dy by dx. Why they had given? Na? We can calculate dy by dx from here. What do I get? X square differentiation is 2x by 4 will give you x by 2. So dy by dx has to be equal to x by 2, and from there you will see that x is 1. That is the point. When it is about to slip, x equal to 1. X could be minus 1 also. This side also you will get by the symmetry. Let's consider this. So once you put x is equal to 1 into this equation, you will get y. Y max. Right, when it is about to slip, up to that height you can have it. It's going to be 1 by 4 meter, otherwise 25 centimeter. So this is a nice problem comparing angle of repose problem in this parabola. And there was one hemispherical bowl, I'm sure you would have seen PYQ question, and similar concept we can use there as well. Okay, next problem. A light string passing over a smooth light fixed pulley connects two blocks of mass m1 and m2. If the acceleration of the system is g by 8, then the ratio of masses is. Actually, you know, this particular problem is given in CET exams, in NEET exam also, like a formula, they remember it. Generally, IIT aspirants, what will they do? They write free body diagram to that m2g minus t equal to m2 into a, t minus m1 in g equal to m1 into a, solve it, eliminate t, get acceleration, alright? But actually, the NEET aspirants, directly they will remember it as a formula, very easy also. I'm sure some of you might be aware of it. So the acceleration would be net unbalanced external force. Net unbalanced external force. In fact, external torque you will get. But the perpendicular distance r, if you cancel it, it will become external force here. So you see m2g is trying to rotate it this way. m2g into r will try to rotate this way. m1g into r will rotate in opposite direction. They are opposing. Right? Unbalanced torque we are considering. Multiply with, divide with r, you will get unbalanced force. Divided by total mass, total inertia of the situation. So same kind of formula you will get even in rotational mechanics also. Then here, let's suppose this pulley has inertia and no slip condition. That also we can do. That I'll leave it for later. But net unbalanced force, assuming that m2 is more, alright. So this becomes m2g minus m1g. That is unbalanced force. If m1 and m2 are equal, it is not going to accelerate. That excess weight that you are getting, that is going to produce unbalanced torque. Okay, divided by radius will give you unbalanced force. What is the total mass? m1 plus m2. That is going to be the acceleration, and that acceleration they had given it as g by 8. All right, g by 8 they had given. That means what? m2 minus m1 divided by m2 plus m1 equal to 1 by 8. That is all you have it. Cross multiply. What do I get? 8m2 minus 8m1 equals to m2 plus m1. Take m2 terms one side. You will have 7m2 equals to 9m1. Otherwise, m1 by m2 you can write it. They are asking m1 by m2 any ratio. I think you need to check it based on the options here. So if I go for m1 by m2, it will become 7 by 9. The heavier one would be 9 parts and the lighter one is 7 parts. You have it. So it's very simple formula. I hope you remember this. It's going to be very useful in solving the problem just like this. It's like a shortcut type. Okay, let's go on. Similar idea we'll use. Okay, same idea I'll use. This is also PYQ. As per the given figure, a weightless pulley P is attached to a double inclined frictionless surface. The tension in the string is, friction is not there. Tension we need to calculate. Okay, fine. First of all, what are the unbalanced forces? You will have one unbalanced force like this, m1g sine theta 1. Theta 1 is 60, m1 is 4. We will substitute it in that later there. So it is trying to rotate this way. And this guy is trying to rotate in opposite direction, this pulley. So m2g sine theta 2 is going to pull it this way. Net unbalanced force, let us assume that this is stronger. If both of them are equal, it is not going to move. Let's say this is stronger, then what do I have? m1g sine theta 1 minus m2g sine theta 2. This is a net unbalanced force in the direction of motion. m1g cos theta, those are all perpendicular to direction of motion. We don't have to worry about because they're balanced by normal reaction there. This is net unbalanced force divided by total mass will give you acceleration. So first find acceleration. There will be a shortcut formula also to find tension, but I am leaving that to you. You can explore it and try to get it. But this idea, so m1 and m2 they are given. m1 is 4, m2 is 1, g is taken out. 4 into 10 is 40, sine 60 is root 3 by 2 minus 2. This is 10 into 1 by 2 divided by 4 plus 1, 5 I get. And that is given as acceleration there. So 5 2's here and 2's here. So this 2 gone and this 2 gone. What do I get? 4 root 3 minus 1 is the acceleration I am getting. Once I have acceleration, right, I can write free body diagram for one of the blocks to find the tension. Maybe let us take this one only. Let's say 4 kg block I will consider. You have tension in this direction and m1g sine theta is down there. So we can find acceleration formula. So what is that? You will have m1g sine theta is in the direction of acceleration minus t equals to m1 into a, the same acceleration we got. Otherwise t equal to m1 into g sine theta 1 minus a. Now we can substitute the values and calculate it. m1 they got 4, g 10, sine theta 1 is root 3 by 2. Alright. A is how much? 4 root 3 minus 1. Minus 4 root 3 plus 1. So you see here, this is 5 root 3 minus 4 root 3. Root 3 plus 1. So 4 into root 3 plus 1 Newton. That is going to be the tension there. So that's very simple idea. It's a little bit of simplification. 2 levels are there, but otherwise still the problem is very simple. If you focus on only on the forces along the incline. I hope you are comfortable with it. Let's go on. If you have any doubts in between, right, you can put a comments down there. I'll be very happy to get back to you and clear the doubts. Okay, let's move on. In the given arrangement of a doubly inclined plane, 2 blocks of masses capital M and small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown. Okay. So how is it different? You have friction here. Earlier problem you didn't have friction, but now you have friction here. Friction coefficient is 0.25. The value of small m for which capital M, which is 10 kg, will be moving down the incline with an acceleration 2 meters per second square. They gave acceleration. We just have to calculate small m. Alright, let's move on. For the first one, I'll write the unbalanced force we can write directly. If it is coming down, right? So this is capital Mg sine theta 1 is in the direction of acceleration. But friction will be opposing it now. F1 will be there. I'll substitute F1 formula later. And this guy is going up, right? When this goes down, this will go up there. And so small mg sine theta 2 is opposite to acceleration. And as it is going up, even friction will be opposite to acceleration, F2 there. So net unbalanced force, if I write, the forces which are in the direction of acceleration, only capital Mg sine theta. So capital Mg sine theta is in the direction of acceleration. Friction, both of them are opposite to acceleration. So minus of F1 plus F2 minus small mg sine theta 2. Alright, whole divided by capital M plus small m is equal to acceleration. This is what I have here. And then we can write F1 equal to what? Mu capital Mg into cos theta 1 and F2 equal to mu small mg into cos theta 2. So we can calculate each of them individually and then substitute there. First let us calculate this one. Mu, how much they had given? 0.25. 0.25 is nothing but 1 by 4. Capital M is 4. G 10. And cos 53. Cos 53 is 3 by 5. So M and 4 gone. So this is going to be 6. Right? F1 equal to 6 Newton. What about here? Mu is 1 by 4. Small m we don't know. G is 10. And then cos 37 degrees is 4 by 5. So 4 get cancelled. You will have 2m. So friction equal to 2 small m. Alright. We can substitute the remaining things over here. See what do I have? 40 into sin 53 is 4 by 5 minus F1 plus F2. 6 plus 2m minus mg sin theta 2. So this is m into 10 into sin 37, 3 by 5. Whole divided by capital M. Capital M is 4 there. Capital M is 4. We can write 4 plus small m, which we don't know. And A is how much they had given? 2. So this is a bit of simplification you have here. And this is 8 times 8 4s are 32 minus 6 here. And this is 6m. 2m and 6m you will have 8m. Divided by 4 plus small m is going to be 2 there. Right? In my class, right, this kind of simplification I don't do. Actually, I'll ask the students to do it. I'll just write the equations and I ask the student to do it. But it is online, so I don't know whether you'll be able to do it, right? But we have to complete it. 32 minus 6 is 26. 26 minus 8m is going to be 8 plus 2m. So 26 minus 8 will be 18 and that is 10. So I am getting m equal to 18 by 10, which is 1.8 kg is what I am getting. You can verify my calculations, see whether they are correct or not, but I have done the method. Okay. So usually don't expect the teachers to do all these manipulations. Try to do it yourself. Get the idea at the maximum. Even idea you should try to get yourself only. But still, idea anyway teachers can give, but calculation part you should focus on, believe in yourself and try to do it. So I hope you understood that. Very simple. Unbalanced force by total mass is acceleration. That's the basic idea. The time taken by an object to slide down 45 degrees rough inclined plane is n times as it takes to slide down a perfectly smooth inclined plane. So inclined plane, they are giving problems. You see, continuously you have problems on inclined plane. So they are giving two cases here, case 1 and case 2. Alright, case 2 is smooth. Alright, let's say it is traveling down in time t0 and here it is traveling down in n t0 time. He is saying n times it is taking. Angle is the same, distance to be covered is the same. They didn't mention the distance here. We assume that the same distance it is going. Okay. Now they are asking you to find the coefficient of kinetic friction that is present there. Okay. So what is acceleration here? Let's call this acceleration is A1 and this acceleration is A2 here. Alright. Now connecting these two cases, displacement is what? Displacement is half AT square. Initially you are releasing from the rest, right? Same displacement when you have it, what does it mean? A1 into T1 square equals to A2 into T2 square. A1 into T1 is n T0 square. So you will have n square equal to A2. So this is one equation. But I can use Newton's law to find accelerations. What will be A1? It's a very standard one. Even in board examination you would have seen it. A1 equal to G sin theta minus mu G cos theta. G sin theta minus mu G cos theta. And cos theta, sin theta, both of them are root 2 only. So you will have G into 1 minus mu by root 2. That is A1. And what about A2? A2 is only G sin theta. Alright, that is G by root 2. So you got A1. Alright, this is second equation. You got A2, that is third equation. This second equation and third equation you can substitute in 1. You see what do I get? G by root 2 here, G by root 2 here cancels out. What is left over? 1 minus mu into n square. That is the left hand side you will get. Right hand side G by root 2 cancels out, you will get 1 there. That's all. You do a little bit of manipulation. First, n square you take it to the other side. 1 minus mu equal to 1 by n square. Otherwise, mu equal to 1 minus 1 by n square. That is the answer, you have it. See, I am doing the calculations in a way that you will be attempting in the examination. So try to look at it, connect it. It's like free flowing. I have not planned it or prepared anything. Directly I am trying to solve this problem so that you will get that originality idea when you are seeing the question for the first time and trying to solve it. So it should be more natural. That I think is more useful for the students, giving the ideas. Okay, next problem. The figure represents the momentum time graph, right? Momentum time graph. So whenever you see time graphs, right? Graphs meaning they'll ask about slope or area. Differentiation, integration. Slope is differentiation, area is integration there. So they gave it is moving along x-axis. They have given momentum versus time graph. Identify the regions on the graph where the magnitude of force is maximum. That is what they are talking about. So magnitude of force. How is it related, force and momentum? We need to get it. Generally we write Newton's law F equal to ma, that's all right. But the fundamental way it was described was in terms of momentum. You must know that net force is directly proportional to rate of change of linear momentum. That proportionality constant was taken arbitrarily as 1. So basically F equal to dp by dt, F net equal to rate of change of linear momentum, which is nothing but slope. Yeah, slope of PT graph. They are asking only magnitude. So magnitude of force, when you talk about, it is going to be just magnitude of slope. Alright, we don't have to worry about whether it is positive slope or negative slope. Only magnitude we are talking about. You see the first graph has got positive slope. This is also positive slope, but this is having negative slope there. I don't care, just take the magnitude. Only magnitude we are looking at. The one whichever is having more steepness, more inclined towards y-axis, right? More the steepness. You imagine it is a children park. You slide down, you can easily feel that it is less steeper than this one. Imagine you are sliding, you are sitting here and sliding like this. You will feel that this is much more steeper. The one which has got more steepness will have more magnitude. That means C is the answer. Answer to this would be the region T2 to T3. Answer is in the region C, it is going to have maximum magnitude of force, and that to negative force, meaning retarding force. This you see momentum is decreasing, that means speed is decreasing. But anyway, magnitude nevertheless is there. You have maximum value. Okay, next. As shown in the figure, a 70 kg garden roller is pushed with a force of 200 Newton at an angle of 30 degrees with a horizontal. Normal reaction on the roller they are asking. So it's a very straightforward. So you see here, it may have acceleration horizontally, may not have acceleration horizontally, but vertically it doesn't have acceleration. It is maintaining contact with it. So that's what we are going to look at it. Acceleration in vertical direction is 0. That means net force in vertical direction has to be 0. What are the forces vertically acting on it? There is mg. Okay. Because of mg, the sphere will press the ground down. Action to reaction, ground will press it up. That is normal reaction. That's what you are actually going to calculate it. In addition to that, there is external force and it is inclined. So we can resolve this into components. Horizontally, you will have F cos 30. Don't worry about it. Just focus on vertical forces, F sin 30. So if you focus only on vertical forces, F sin 30 and mg, those are downward, normal reaction upwards there. So N should balance F sin 30 plus mg. F they had given 200 newtons, 200 into sin 30 is 100 plus mg, 70 into 10, I am taking 10, okay, 700. So totally 800 Newton is the normal reaction. You have it. Very simple, I hope. Let's go to the next problem. A stone of mass 1 kg is tied to one end of a massless string of length 1 meter. If the breaking tension of the string, breaking tension they are saying, meaning if the tension is more than this, the string is going to break. At that moment itself it may break. A little more it will definitely break. The maximum linear velocity the stone can have without breaking the string while rotating in a horizontal plane. So it's a circular motion. Alright, the string is rotating. So imagine this is a horizontal plane, string is rotating, particle doesn't rotate, particle goes in circular path, string is rotating. So he is asking what is the maximum speed with which particle can move so that the string doesn't break. So first of all, why do you need tension in the string? Why should you have tension in the string? Because whenever a particle goes in circular motion, you know that it experiences centripetal acceleration. That's a requirement. Without centripetal force, circular motion is not possible. Without centripetal force, a force perpendicular to velocity only can change the direction of velocity. Force in the direction of velocity or opposite to velocity will change the magnitude of velocity. So centripetal force is provided by tension here, right? So centripetal force, which is tension here, is actually m into v square by r. Now they are asking v. Let us calculate v. How much is that? R into t by m under root. They are asking v maximum, and that will be root over r is nothing but length of the string into t max divided by mass. That's the answer, you have it. Now we can substitute the values. What is the length of the string they had given? 1 meter. Tension maximum is how much? 400 Newton. Mass of the particle is also 1. You will get 20 meter per second. That's the maximum speed it can go. Less than that is okay, but more than that string will break. Once the string breaks, it will go tangentially, right? It goes tangentially without centripetal force. Right, next problem. As shown in the figure, a block of mass 10 kg lying on a horizontal surface is pulled by a force F acting at an angle 30 degrees, okay, with horizontal, where friction is given. I think this is mu s. Mu s is 0.25. The block will just start to move for the value of F. You see some markings, you can see fly is moving around here, probably because of the light there. So yeah, that's anyway. A fly is also attending our classes. Okay, very good. So they are asking you to find what is the minimum value of F so that the block can move. Okay, let us see that. So let us consider that limiting situation where it is about to move. Limiting situation, when you consider, right, friction would have reached limiting friction, and the value is mu into n, mu s into n. Don't write mu k into n, mu s into n there. So now this force, if I resolve it, I see that there is a horizontal force F cos 30. Alright, there is a vertical force F sin 30. Right, without friction this block will move right side. So friction has to hold it. So friction should oppose this F cos 30 and it has to be in this direction, and that is limiting friction we are talking about when it is about to slide. These are the horizontal forces. There is a gravity obviously vertically downward, and when the ground is pressed, normal reaction will be generated there. So this is the situation you have. Let's write the equilibrium condition horizontally. F cos 30 is a limiting friction. Limiting friction is nothing but mu s into n. Okay. Vertically, if you look at it, F sin 30 plus n equals to mg. So that's the second equation I have it. First equation and second equation. What I will do is, from the second equation I will take n and substitute in 1. Let's see how it goes. F cos 30 equals to mu s into n is how much? Mg minus F sin 30. Alright. Now I will bring all F terms one side. So what do I have? F into cos 30 plus minus of minus plus, it will become plus mu sin 30. Alright. And that is going to be mu mg. Right. They are asking you to find F there. So what is F? You will get mu mg divided by cos 30 degrees plus mu sin 30 degrees. This is going to be the answer. You can substitute the values. What is mu? 1 by 4.25. Mass is 10 kg. G is 10, meaning 100. 100 into 0.25 will give you 25 numerator. Numerator is 25. What about denominator? Cos 30 is root 3 by 2. And mu is 0.25 into sin 30 is 1 by 2. So 0.25 into 1 by 2, 0.125. I think you will get some fractional values. So simplification, I am leaving that to you. But we can go on with the next problem there. A small block of mass 100 grams is tied to a string of string constant 7.5 Newton per meter and length 20 centimeters. The other end of the string is fixed at a particular point A. If the block moves in a circular path on a smooth horizontal surface with the constant angular velocity 5 radian per second about point A, then the tension in the spring is. So this is also a very good question. I don't know why students are missing out a lot. It's a simple question only, but little idea you need to have. So basically the particle is moving in a circular path. Okay, first part is it is circular path. And what is connecting there? only the spring here, not the string. Earlier you see there was a string connected, here you have string connecting it, and length of the spring whatever you have, right, and that is the radius of the circle because of the spring length, right. Spring length is actually more than elongated, more than natural length there. It is going in a circular path. They gave omega also there, and because the spring force is there, it is having, because there is a spring force, it is having what? Centripetal force. So centripetal force is there. Spring force is centripetal force there. So spring force equals to m omega square into L. But what is spring force? Spring force is basically K into elongation, and that is equal to m into omega square L. This is in one equation there. Very good. Okay. But what is elongation? Elongation is L minus natural length. I think they gave the length. What is this length? This is natural length 20 centimeters. Elongation length is not 20. It will be more than that. That we need to calculate. So if I substitute here, then what do I get? K into L minus L naught equals to m omega square L. So you take L terms one side. What do I get? KL minus m omega square L equal to KL naught. Otherwise L equal to KL naught divided by K minus m omega square. This is going to be length there. Once I have the length, then elongation I can calculate. Alright. So let us calculate elongation. What is elongation? L minus L naught. Alright. So that is going to be KL naught divided by K minus m omega square minus L naught is what you get. Alright. That's what I have. So if I take L naught common and then take LCM, K will get cancelled out. You will get m omega square divided by K minus m omega square. That is elongation. Once I have elongation, then I can find the spring force. Spring force is nothing but K into elongation. So that will be K into L naught into m omega square divided by K minus m omega square. So that is the expression I am getting it. So you can substitute the values and try to calculate it. I hope you understood that. So spring length is not L naught. L naught they had given 20 centimeters. L we have to calculate. L is natural length plus elongation. That is the radius of the circle in which the particle is moving. So that's a basic idea. Good question. So let's conclude here for the time being. The remaining part of Newton's law, I'll take it in next session. So I hope you are following it. If you have any suggestions, ideas as to how you want me to cover things, I'll be very happy to adjust things. So until next time, tomorrow, goodbye. Wish you all the best.